And next, we are moving on. Our next speaker, Dr. Olaf Witkowski, founding director of Cross Labs, discuss the Interwoven future harmonized biological and technological minds. The floor is yours. Thank you.
Perfect. Thank you. I will use this. Thank you. All right. First, of course, I would like to thank everyone organizing this, and especially Venerable Yifa for having me here. I want to share that we had so many jazzy conversations already, and I'm so happy, in spite of having my son being born very, very soon, I could make it here. Yeah. Thank you so much for sharing and all the discussions. Maybe because we haven't maybe met before, some of you, here are a few words about my background. I came from basically computer science and maybe cognitive science as well. I started off as trying to decode old archaeological artifacts, trying to make sense of meaning that is sometimes lost. And I went into, after creating a few businesses, I went back into research because my heart was there. I wanted to understand what is the emergence of communication between any agents. And of course, I started with simulation because that was my strength. And then I went to the US at the Institute for Advanced Study. We focused on the emergence of awareness and how come this comes about in our universe, and try to understand that from physical laws and information science. I came back recently, a few years ago, to Japan and founded Cross Labs, where I focus now on hybrid intelligences, and that's what I would like to share with you today. Maybe I'll mention a few other side adventures. Actually, I'll mention only one, which is the Center for the Study of Apparent Selves. We have Bill and Thomas. Lisa is not here today, a few others with us, and yeah, I want to thank everyone who collaborated with me in all this research that you'll see. It's not just my effort, it's really a group effort. If anyone is coming to Kyoto, I invite a few of you, and a few of you are coming already, please visit me in Kyoto. And we have a nice center where we study diverse types of intelligences and cognitions. Here are a few examples of the type of things we do. Focus on the science of collective intelligence, but also open-ended learning. You know how you always need data, more data, in order to learn? That's not true. It turns out that you can set up open-ended machine intelligence that doesn't need to do that, a bit like a mathematician would discover new things, and hopefully we include that in the future of AI. Also, we are interested in experience, and we'll share a little bit about that in a second. Really, all of this is at the intersection of three things that are very close to my heart. One of them is, of course, AI, which is my background, but also artificial life, which is the study of synthetic biology, but also life as it could be, as we haven't discovered it yet, maybe alien life as well. And finally, the study of artificial neurophenomenology, or a study of experience, awareness, and consciousness. I want to be very honest with you today, and my background, although I've been exposed for the last 8-9 years to Buddhist philosophy, I'm no expert, and I would really welcome your feedback. And if we don't have time to chat today, please email me. I'm easy to reach, and we'll always answer your emails online. So please reach out with your comments. And I want to explore today our resonance and really be very modest in what I would pretend to know about what you are expert in. Let me start with talking a little bit about diverse minds. Suspending our judgment about what they should be and what we are sure they are about, because I also don't really know. I'll introduce my first field. That's what I graduated and got a PhD in. Artificial life is the study of life as it could be. It's not simply biology. You could call that universal biology, and a lot of that is within various substrates, chemistry, digital, we include everything. But also, we include mixing them together, mixing and mashing them. And a few examples are here. You go into neural, cellular, digital worlds and mix them together. Maybe this study by our colleagues, Mike Levin, Josh Bongard, and so on, created xenobots, also anthrobots, that mix the digital kinds of life, that mix that into cellular, life that we know about. And it's really hybrid, right? It's not simply robots, it's hybrid robots that mix with our known biology. This is maybe the summary of my view today, and it's rather simple, and you're familiar with this, of course. This has a lot of intersections with what you're expert in. I'm more familiar with maybe Kyoto School philosophy, and also with anything linked to enactivism and so on. This is really about the interaction between human and AI as a loop. And I want to emphasize that and give you my take-home message in case I don't finish my slides like a good academic. We're used to that. At least you'll have this to go on. I think offloading intelligence is very, very different from augmenting it. And I don't think my field in AI realized that yet. We talk about it, but we don't really have the solutions. And we're not looking strongly enough. The example that often I get in conversation is Google Maps. Google Maps, we use it in order to orient ourselves, and in the end, we can forget about orienting ourselves in our brains and minds. Really, it's not necessary. And we're replacing one by one, a bit like using a calculator, right? With a very narrow channel of communication between the tool and us. We are replacing one by one the pieces of cognition. Is this augmenting my intelligence? Is it augmenting my understanding and care for society and everything? I don't really think so. ChatGPT, maybe another version of the same thing. Doesn't that sound sort of dangerous? Slippery slope, but we can be saved. And this is my favorite example, the Soroban, many names in different cultures. I've never really learned how to use it properly, but I learned a little bit. And this little bit really increases my understanding of mathematics quite exponentially, really directly. I understand it incorporates knowledge and power into my mind. Those kind of tools are really, really valuable. And it's not only about control, it's also about how you can incorporate sensing through tools in an active way. You can sense like using a blind person's cane or an active different sensor that fellow scientists made. Even just writing in a notebook is so valuable. This really expands your mind. We want the tools on the right side. We want less of the tools on the left side. We can create those for a time just to test them out. But let's transfer more to the right side. So, when you look at these kind of tools, what are we finding out? I just found out that my clock is wrong, has been running from the beginning of the session, so that I don't know what time I'm at. Please let me know. Really, offloading intelligence is great, but we should be careful what we wish for. And there are a bunch of studies we do. There is theoretical computer science, basic studies that we do. And it turns out that by upgrading your machine, the theory says, we don't get more compute. Actually, we may end up achieving less possible functions than we started with. Isn't that amazing? It's very surprising. We're very surprised by those results. But this delivers same kind of message. We have this control and perception kind of loop, right? And of course, those are both very important. And both of those, we have to increase the bandwidth with. So the kind of basic picture is that you have a sort of self, right? And you're interacting with something, the environment or the AI. And you don't want, of course, you want a tool that mediates and helps you interact with the environment and make society better. But what you want is something that extends yourself, right? You want more bandwidth, more connectivity, a more integrated self that is made with the tool, like a prosthetic. In our research recently with CSAS, we talk about light cone augmenting kind of technologies. And there are many examples in science fiction, but we want to pick the right ones that really expand, augment the cognitive and caring self. something like Gmail delegation. If you have a company, you delegate to your employees, your team members. That's great, but you want this to be an extension of yourself where you still sense the end. And if you don't know what your employees are doing, maybe you're doing it wrong. This kind of integration is very important. There are physical limitations, and we do research on that too. There are many constraints, and those constraints may come from your substrate, your embodiment, and maybe the physics that are very different in biology, different types of biologies, let's say in plants, or maybe in silicon, maybe in dominoes. You can compute with so many things, and each have their own constraints. So I want to explore a little bit of that and give you I'm just giving examples now, so you can relax and just enjoy the ride. So my picture I usually explain this with is how to meet with an alien. It's really like the sci-fi kind of picture, right? And what you're going to find is that it's hard to recover meaning from a different substrate. It's even hard when it's human, archaeological residue from different cultures that are not so far ago. This is the work from my thesis. Trying to recover meaning from those quipus and in the Andes is extremely difficult. Just a few hundred years ago, those are pieces of art simulating how we would make the meaning of our own society now in the future. Very difficult. And arguably, alien AI minds are no different. I want to insist that there is a sort of Barnum 4 effect in this, in which we think we know what ChatGPT is all about. It's very human-like. Really, I understand everything about it. Yeah, it's thinking like a human. I interact with it. I know what it's doing. Well, no, I call it in a different talk that I'm giving. You can find that on YouTube. I call those Lovecraftian cherries, because Yann Lequin says that reinforcement learning has a very sort of cherry on the top here. And we're just seeing the cherry on the top. This is a monster. No judgment. It's not a positive or negative monster. It's just very different from our own cognitions, and we have to recognize that. Ooh, I'm out of breath. I should slow down a little bit. But also speed up, because I'm an academic and I have a lot of slides. So I think we have tools from computer science, and we know that surprisingly, we're pretty good at recognizing other agents. There are many surprises like that. And we took advantage of some of those surprises to trying to investigate that. And we made this robot. That's a collaboration with our folks at Waseda University, here Dominic Chen and colleagues. We made a robot in which we put a bunch of microbes. Turns out, we're not very conscious of our surroundings. A bit of our families, but how about all the viruses, bacteria in our guts, just around us? There are trillion, not thousand, not million, it's trillions of individual agents that are around us that form what makes us us. And yet, we're not very connected to them. So we thought, let's put some of those in a box, make delicious pickles, and communicate with them. I think sound is not going to come out, but anyway, this is in Japanese. We interact, we can actually talk to those robots. It translates between microbe language to our language. I'm skipping the details, but basically this uses similar technology to transformers and language models. And turns out the best way so far to interact very deeply with them is to engage with them in games. And my favorite game is the game of Go, Weiqi, or different Baduk, and so on. And also chess. It turns out you can feel the personality and emotions from a different creature through a very narrow channel, if you design it right. So we did this kind of stuff. We also, I added this slide because someone mentioned it, as a joke probably, but actually we do it. And I think those tools, like Jundo very nicely introduced, I think we can use technology to increase our sense of empathy. And if anything, this is the most important. This teaches us, in a very mentorish way, how to extend ourselves and care about others. And let's make use of this technology if possible. And we are also interested in any kind of agents, so also AI to AI interaction. My personal practice actually doesn't come from meditation. It comes from when I was a teenager, I shared with a few of you, it comes from hypnosis. And I really got into it. And later when I touched on meditation, now it's an interpretation of hypnosis to me. So this is the tool that I exploited, and we made basically a sort of technology that a device, like a set of devices, that augment somehow your capacity to control your own emotions. And it is so nice to have had an introduction to my talk, basically. I feel like, this was meant to be, that Jundo introduced those concepts and how it could be very, very useful. Also, it's very dangerous, possibly, technology. We have to be very careful how we use it. You can modify a lot of things, perception, sense of agency, and we don't only create a technology, we do research around it to make sure it's safe. You can also use it for simply entertainment, and you can modify on the fly your Netflix movie so that it fits and it puts you in the right mood and doesn't get you too excited before you go to sleep or too worked up in any kind of way. You can design basically everything to tune and have a sort of self-regulator, like a sort of mentor that you would be still sensing through and controlling through, if that makes sense. We really want to understand what's the structure of experience while doing that. And we think that without having the science of experience, we won't find out. So we make mathematical theories and try to apply them and back and forth, and we think there is no other way. And we studied structure of color experience, language, sound experience, all of those, I think are very important. We shouldn't drop that side of cognitive science while we're making the tools. In fact, we should have a back and forth. All right, I'll finish on this now. I sped up very nicely. All of this is about achieving harmony, and it was the title of my talk here. There is a sort of conventional transitions in cooperation, and scientists would say often that we know everything about love and how it emerged. It's artificial, it's just designed in your brains and your minds, in your bodies, in your genes, how you are cooperating with each other. And usually you're cooperating with things that are very similar to you. And we start with the left side, where you love only thyself. But then we might, as we build up more complexity and caring complexity in our not only genes, but also technology, we have the opportunity to love a bit further and extend the kinds of love that we have. So how do we do that? Really, we could have reached love as it could be. We could reach something that is, so this is recent conversations that we had with Mike Levin and others. We could reach unconventional. And I would ask you, does it sound like non-dual love? Something that reaches beyond your own embodiment. Possibly something very far away from something very similar to you that is easy to love. Can you love something that is further and further and possibly extend your light cone of care to everything and everyone, every life form? So we study a lot of moral consideration, theories, but we also push it towards what we call autopoietic care. So you'll find the papers if you Google my name and others here. And I think we had some introductions from Thomas and Bill already about the kind of stuff that we do. And I would just want to end on this, that interweaving with technology is going to be very difficult, but also it's an adventure. We are accepting that we are not this permanent, self-defined self forever, and that will never change. On the contrary, we have this opportunity to change ourselves and design our own change, and accept that we are not our final form. Humans are not, as they are, the center of everything. Maybe not quite yet, but maybe there is something underlying that is more important, and we want to be very open-minded about this and really not stop any strand of science that could bring joy, happiness, but also care and further cognitive development to all of humanity. And with that, I would like to thank you all. It was very fun to have you.